Hello once again, 7th graders, and welcome back to my YouTube channel. Today I wanted to introduce the concept of number bases, but first we have this story about a boy named Tom working in a tea shop, and he has to weigh out these packages of tea. And there's about a 5-minute story there on page 28, and if you're in my live class, of course, last week I asked you to take a look at that. So when we're going to fill out this table, again, what this table is telling us here, for instance, if Tom has if he has a 10-ounce amount of tea he needs to weigh using one of these little balance scales, so he won't use a 16-ounce weight. An 8-ounce weight will help. The 4-ounce is going to be too much, so I'll leave that off. 2-ounce will get us, because 8 plus 2 is 10, and then of course we won't want the 1-ounce one on there. Notice these the masses of the weights used, 16, 8, 4, 2, 1, those are all powers of 2. That's not an accident, incidentally. So you're to complete the rest of exercise 61 here, doing the same thing. And again, I would encourage you, so like let's, for instance, we do 13, I would encourage you to just work your way down. So 16-ounce weight is going to be too much, so leave that off. 8-ounce weight, okay, so he needs 5 more ounces. Okay, we'll use a 4, but not the 2 and the 1. 1, 4, and 8 will add up to 13. Obviously, we get to 16. We can just use the 16-ounce weight and call it a day. 17, I'll use the 16-ounce weight plus the 1-ounce weight, and so forth. I'll let you go ahead and finish out the rest of this table, and I'm going to continue our discussion now with this idea of what we're going to call radial expansion of base 10 numerals. So if I take, for example, let's just take the number 10 right now. If I were to describe this in terms of base 2, I would actually write 1010 in parentheses with a base of 2. So we're expressing the numbers, when we're doing this, we're expressing the number of the fewest available digits. When a number is expressed with fewer available digits, or more for that matter, you'll always indicate it with a subscript that tells the reader the base being used. So in this case, as I was saying here with the 10, you may look at this, and I missed my multiplication signs there. When I'm saying base 2, here's what I have to think of this as. I have to think of this as being, this right here is representing the ones place. Why the ones place? Because it's 2 to the 0th power. This is my ones place. This will be my twos place. This is going to be my fours place. This is going to be my eights place. Some of you may have already seen something like this before. We call this, of course, binary arithmetic. Yes. In this case, when I'm writing a base 2 numeral, there's only 2 digits available, the 0 and the 1. And you might have been able to do this in your head without any real issue. But I would tell you, if you looked at this and said, man, I don't know where to start, it's okay. Just take 10 and start dividing by 2 repeatedly and writing down what the answer is over on the side here. So I see that 2 goes into 10 5 times, but then I'm going to write remainder of 0. So why would I write remainder of 0? Just trust me on this, okay? Now I'm going to divide by 2 again. 2 goes into 5 2 times. Now it's a remainder of 1. And 2 goes into 2 1 time with the remainder of 0. And I'm going to divide by 2 again and say 0 with a remainder of 1. Now I can stop. Check this out, folks. These digits reading this direction right here, that is exactly what I'm writing down. 1 0 1 0. Reading up from the bottom. 1 0 1 0. See that? Yeah. So that's what we're doing with these problems. I hope that makes sense. Again, the 0 represents no ones. This 1 represents a single 2. This represents no 4s, and this one represents 1 8. So it's an 8 0 2 0. Add these together. Of course, you get the 10. All right. So let's try it now with 23. Again, as I look at this, I may get a little concerned about where to start, and that's okay. Just take 23 and divide it by 2. 2 into 23 goes 11 times. It's a remainder of 1. I'll divide that by 2. And 2 goes into 11 5 times, again with a remainder of 1. 2 goes into 5 twice, again with a remainder of 1. 2 goes into 2 one time, remainder of 0. And then last one, 2 into 1 0 times, but now there's a remainder of 1. Again, you're going to read bottom up as you go to write your answer. You're going to say 1 0 1 1 1. I'm going to put it in parentheses like so. And then I say base of 2. Again, folks, I know this is correct when I go check it because this one should represent the ones place. This is a 1. Okay, so I have a 1. I'm going to add on. This is going to represent the 2's place. That's a 2, a single 2. This represents the 4's place, 2 to the second power. And so that's going to be a 4. There's going to be nothing in the 8's place and something in the 16's place. So I add these numbers here, 16 plus 4 plus 2 plus 1, and it's 23. Just like I was trying to find in the first place. Let's try it with 68. So 68 divided by 2 makes 34, no remainder. Write that down. 2 into 34, looks like that goes 17 times. Oops, I forgot to write down the 0 here. All right, and let's continue. 17 divided by 2 gets us an 8 with a remainder of 1. I'll do it again. Get 4, remainder of 0. Divide that by 2, I get 2, remainder of 0. Divide this by 2, it's a remainder, it's a 1 with again a remainder of 0. There we go. And divide that by 2, now I've got 0 remainder of 1. So that's going to tell us once again, I'll just use my highlighter pen. It's going to tell us our digits that we're going to write bottom up. We start with a 1 0 0 0 1 0 0. I wrap it in parentheses and I put a little subscripted 2. Again, when you go to work this backwards, you're simply looking at these digits. It's always the ones place first here. That'll be the twos place. This is the fours place. So I've got no ones. I've got 1 2, 1 4, no eights. There's 116. Okay. This is, yeah, so I've got nothing there in the eights place. 16 plus 4 plus 2 plus 0 is going to equal 22. So that's my standard form numeral for 10110 at a base of 2. All right. I hope that explains it well enough for you. Feel free to watch the video again. Understand that how that repeated division is going, with the remainders, is going to unlock the actual sequence of digits, the order you will write the digits on your base 2. It also tells you how many of them you need. I want you to complete up through exercise 63 today. That's basically 61, 62, 63. And I will talk to you again tomorrow. I plan to do a quiz within 2 days. So, and these, there's going to be problems like these on the quiz. Have a great day, everybody. Be good for your parents, and I'll talk to you again soon. Be sure to subscribe to my channel and smash that